We're going to begin with a short review of ellipses and then solve the problem. To skip directly to the solution, look for the bookmark in the video description. If you're like me, you often forget the relationship between the major and minor axes and the distance to the foci of the ellipse. So we can rederive that quickly by noting the definition of an ellipse is the set of points such that the sum of the distances from any point to the two foci is going to be constant for any points on this ellipse, including these randomly selected points P and Q. We're going to derive the relationship between our distances by picking some convenient points and finding their distances to the foci. Let's pick point P over here at one end of our ellipse, and we find that the distance from P to our two foci is A minus C plus A plus C. Another convenient point is Q, which is on our y-axis. We can use the Pythagorean theorem to find the distance from Q to our two foci. Since the sum of these two distances to the two foci for both of these points is going to be equal, we have 2a is equal to 2 times the square root of b squared plus c squared. Dividing by 2 and squaring both sides, we have a squared is equal to b squared plus c squared, the relationship that I always seem to forget, but it's pretty easy to rederive. Now let's return to the problem. Let's find our 5 solutions by using the Pythagorean theorem on these two factors. Let's replace these 5 complex numbers with points that are in the Cartesian plane that are also on the ellipse. So our 5 points are 1, 0, -1 plus or minus root 3, and -2, root 2, and -2 minus root 2. All 5 of these points are on our ellipse. Looking at these last 2 pairs of points, we see that there is symmetry over the x-axis. So our ellipse looks something like this, where we have 1, 0 as one of our points, and then at x equals -1, we have plus or minus root 3 up here and down here. And when x is equal to -2, we're at plus or minus root 2. The equation for an ellipse that's centered over the x-axis like this looks like, let's multiply by the denominators to get rid of the fractions. Since the point 1, 0 is on our ellipse, we can plug in for x equals 1, y equals 0. Solving for a squared, let's try the point -1 root 3 on our ellipse. Plugging in for x equals -1, we note that -1 minus h is the same thing as h plus 1. And similarly with the point -2 comma root 2. -2 minus h, the square of that is the same as h plus 2 squared. Let's make our substitution 1 minus h squared in for a squared in these other 2 equations. Looking over these 2 equations, let's see if we can get rid of this second term on the left-hand side. We'll do this by multiplying our first equation by -2 and our second equation by 3, and then adding the 2 equations. When we add these 2 equations, the middle term 6 times 1 minus h squared disappears. So this first term, when we add it, let's factor out the b squared. Let's divide both sides by b squared and multiply out the left-hand side and combine like terms. This is what you get, and let's solve for h. H is negative, which is kind of what we predicted the center of our ellipse to be, to the left of the y-axis. Now we can solve for a, and a is positive since it's the major axis. We'll take it equal to 19 over 10. In our problem statement, we're solving for c over a. Let's find out what b is, and then we'll solve for c. We can use this equation again, and we'll plug in our values for a and h. We'll collect the terms that include b squared on one side of our equation. We'll save a little bit of time by not multiplying things out just yet and using the difference of squares factorization with this fraction. Using the relationship that we derived at the start, we can plug in our values for a and b and find a common denominator. Again, we save ourselves a little bit of time when we don't multiply things out right away. Taking the square root of both sides, the problem asks for c over a. This is 1 over root 6, but they want the answer in the form of the square root of a fraction. And they want the sum m plus n, which is 7. That's option A.